My name is Greg Powley. I'm with Risk Sciences International, which is a consulting firm based in Ottawa. We do work in many of the areas described here: food safety, pharmaceutical safety, etc., environmental health generally, and very interested in this topic. And one of the things that interests me already from the discussion this morning is the notion of comparisons between chemicals, not just looking at a single material, but how they can be compared to others. Recently, I was on a National Academy of Sciences committee on developing a framework for chemical substitutions. Thankfully, for this committee's sake, nanomaterials were not included in the agenda for that committee, but they probably should have been in a broader perspective. So I'd like to, without any further ado, as Bruce said, yeah, I'm standing between you and content. So our first speaker this morning is Dr. Alistair Boxall. He's a professor in environmental science at the University of York in the UK. His research focuses on emerging and future ecological and health risks associated with chemical contaminants in the natural environment. He's a member of the Hazardous Substances Advisory Committee of DEFRA. That's the UK Department of Environment, Food and Regulatory Affairs. Is that right? Not anymore. You're not a member of the committee?
I used to be.
Okay. Former member. But you get the idea. The government would like his advice. He's a chair of the Pharmaceutical Advisory Group of CTAC. Not anymore. He is not a specialist in updating his bio on his website, but he does advise at national and international organizations on issues related to chemical impacts on the environment, and he publishes extensively. He's coordinator of a project called Capacity, which explores methods for monitoring pollution in cities. So, Dr. Boxall, and thank you for coming so far to visit us today.
Thanks, Greg. So I thought I had updated all the websites, but obviously one has crept through. What I'm going to talk about today then is some of the work that we've been doing on exposure to the environment and potential risks to human health. I'm going to spend a little bit of time talking about what we've done, but then I'm going to talk a little bit about where we're heading. And this is in terms of exposure of humans to nanoparticles, but also contaminants more generally, just to give you a feel for sort of our direction of research. So, this morning we've already heard a lot about the potential applications of nanotechnology. Obviously, if you consider all of those different applications, there is the potential for emissions to the natural environment. So this is a diagram we knocked together a few years ago for a paper looking at emissions to different environmental compartments. And if you think about those environmental compartments then, there's the potential then to enter either drinking water, to get into the food chain, so uptake into crops and things like that, uptake into animals, there's emissions potentially into the air. And we as individuals then might be exposed to the nanomaterials in the environment via each of those pathways. And then, obviously, there are concerns or potential concerns about what that could do in terms of our health. Now, what I'm going to focus on today, then, is drinking water. So, a few years ago, so I think this was about 4 years ago, we sort of started this project. We were asked by the Drinking Water Inspectorate in the UK to begin to think about potential exposure of the UK population to nanomaterials, and particularly engineered nanomaterials, via drinking water. So that work was done, so I think it's about 4 years ago. The full report is on the DWI website, so if you just search for either my name and DWI or Karen Tida's name, who's the lead author, and DWI on Google, that will take you to the report, and there's a lot more information in that report on how we did it and the data. But the data are also published, so a paper came out last year in Nanotoxicology entitled How Important is Drinking Water Exposure for the Risks of Engineered Nanoparticles to Consumers. So what I'm going to do is very quickly talk you through how we approach the problem and to talk you through our findings and then move on to where sort of our exposure work is heading. So we were asked to do this by DWI. We spent a couple of months scratching our heads, working out how we were going to do it. And in the end, we came up with a framework that we could use, which was a desk-based exercise to begin to look at the potential exposure of consumers in the UK to different particles arising in different product uses. The way we did that is we considered what's used in the UK. We considered the potential pathways of exposure for different uses. We then did a qualitative assessment where we sort of started to rank things in terms of potential for exposure. And we also, for some of the products, we did a quantitative assessment where we tried to sort of determine what the levels of these materials would be in drinking water sources in the UK. So the first point that we started with was asking the question, what do we use? So here we sort of began with the inventories like the Woodrow Wilson inventory. We worked through those, sort of looking at what products you could actually obtain in the UK. We identified about 126 that we sort of focused on. And for each of those products then, we then tried to pull together information on the characteristics of those products. So what particles did they contain? What were the characteristics of the particles in those products in terms of their size range, for example? What was the concentration of the particles in the products? We also tried to get information on how much was used. Now this I'll come back to later. This was really difficult. So the way we did it was basically go to supermarkets and shops, identify a product range that, say, it would be a sunscreen, and then we'd count the non-nano products and the nano-containing products. And if the nano-containing products were 5% in terms of numbers of all the other things on the shelf, we would say that the penetration was 5%. So that was the best way we could come up with an approach to do that. So using that type of approach, then we sort of get these big tables on usage, looking at the different products. So here's just, you can't read it, but we got the different product names there, the type of particle in those products, and the type of product, what category it falls into, and then the route of exposure by which it would enter the natural environment and ultimately get into drinking water supplies. So the qualitative exposure assessment then, what we did was we pulled together this information on usage, on the concentration of the particles in the different products, the release pathways, so whether it would go down the drain into the sewage network, whether it was going to a landfill site, whether you had runoff from hard surfaces, perhaps entering directly into rivers. And then also we were considering the type of product and what the emission potential of the particle from a product would be. So if you had something, so we got this diagram here. This is a diagram that Stefan Hansen at DTU in Denmark, he developed this approach where basically you apportion different particles to different product types, and from that you can get a likelihood of release. So some products you would get a high likelihood of release to the environment. Others, like the hockey sticks that we've heard about, that likelihood would be very low, and you can begin to sort of categorise the sort of products based on that type of approach. So this slide just shows the result of that release analysis. So what we have on the x-axis here is all the different particle types. We've then characterised them in terms of the environmental exposure as expected. You've got a possibility of exposure, or you've got no expected exposure. And then we have a few that we weren't able to classify, so they're sort of unclassifiable. So bringing all that together then, the way we approached it is we developed tables like this, where we'd sort of take each of those parameters, so we've got the different particle types there, the product types they fall into, we have the release patterns, we have a sort of a binning of the sort of concentrations in the products, we have the potential for the emission, potential for release, the market share, and using all of that information then we come up with an overall score. And then ranking the different materials based on that score, you can begin to sort of say, well, these at the top of the most concern in terms of drinking water exposure, and as you go further and further down the list, those will become of less concern in terms of exposure. So that was the qualitative assessment. And as I say, if you want to sort of look at this in more detail, it is in the paper, and then in the report, we got lots and lots of these tables sort of showing the results of that analysis. So that was the qualitative approach. Now, for substances where we were expecting sort of exposure, we also wanted to do some quantitative modelling. So here we used this approach. So this diagram shows the way we approached it. So what we have at the top there is the different products. So we focused on the products that we'd expect to be emitted into the environment. We then considered the route by which it would go into the environment, and we all used information on the usage of the product, the concentration of the particle in the product, the market penetration to get an emission out into the environment. If it went then to wastewater treatment works, we're pulling information from the literature on potential removal in wastewater treatment to sort of correct for that, to estimate that and what would come out the other end of the wastewater treatment works. And then that would go into an aquatic system, so you've got your river there. That river is then being abstracted. We'd get information on, if it is available, on the removal of the particles in drinking water treatment. And joining all of that together then, we'll then be able to get an idea of what the levels of the particles were in the drinking water that then's going out to the consumers. And this is the type of data that we get then. So what we have here is a range of different particle types. We have the different scenarios that we looked at, so we played with different numbers. So again, in the report, there's lots and lots of these tables. An idea of the particle sizes in the products. And then on this side here, we have different types of drinking water treatment. So we have the conventional type of treatment we use in the UK. We have two other types of treatments as well. And then these numbers here correspond to the particle number concentrations that we're predicting then for each of those particles in the drinking water in the UK. And then that sort of gives an idea of what the potential exposure is. So that's all great, but you then ask the question, well, so what? Does that really mean anything? Do we need to worry about it? And this is really what the DWI was sort of worried about. So we then started to think about how we could begin to take this information and the data we collected to get an idea of whether, this was something of concern in terms of risk to human health. And the way we approached it is we started considering what the potential exposure via drinking water would be compared to exposure from the use of the product. So, for example, if you've got a skin cream where you're applying it directly to your skin, it's likely your just day-to-day use of the product is going to result in much greater exposure than you're ever going to get from the drinking water exposure. So we tried to sort of put it in perspective. So the way we did that then was we sort of asked the question, well, if we consider the drinking water, is the exposure risk greater than the day-to-day use of that product? If that was the case, then you've got a red shading. Is the exposure equivalent to the day-to-day use of the product? That was a sort of bluish shading. And then the last one there is the exposure lower than you'd expect from the day-to-day use of the product? And then you can see here we have a result of that analysis. So we have a range of products here, the particle types in those products. We have an assessment of exposure from the day-to-day use, assessment of the exposure from the drinking water, and then by minusing one from the other, we get an idea of how important the drinking water exposure is. And what we found is actually for the vast majority of products that we looked at, actually the drinking water exposure probably was quite insignificant compared to the day-to-day use of the product. There were only a few sort of examples. So an example might be something like cerium dioxide in exhaust coming out into the road and then being washed into a stream. That might be an example where your exposure would be greater. But there were only a few examples where we sort of found that scenario to occur. So that's sort of just a very quick summary of that study. And that's now gone to the Drinking Water Inspectorate, and they've been using that to inform what they're doing in terms of considering nano in drinking water in the UK. Now what I want to do is just sort of give you an idea of where we're moving in terms of exposure modelling of nanoparticles and also other chemicals. And what we're working towards now is actually developing a model of York which looks at exposure of both the environment of York and humans in York to nanomaterials, but also other sort of chemicals. So this slide just shows part of this work. This is actually aerial exposure, so this isn't nano exposure. This is actually emissions from cars looking at nitrogen oxides, but you could actually think about using this type of approach for cerium dioxide, for example. So what you can see here is we have the road network in York. We know the traffic flows within the road network, and what we can do is we can then begin to simulate the city and do that over time. So using climatic characteristics, we can begin to get an idea of exposure of the city over time. If we then map on how individuals interact with the city, we can then begin to sort of work out, what the potential of exposure of the individual to different pollutants is going to be throughout their lifetime living in the city or visiting the city. So this is our sort of idea, and this is what we're working on. As part of that, we are sort of having a nano component. So we're building on the work that we've done with DWI. We're sort of beginning to sort of get information on the usage of particles within the city. So we're considering different uses, so use in the households, the industry in the cities, use on things like cars, such as the polishes and the paints that we've talked about. North of the city, we have quite a lot of agriculture, so we're considering potential agricultural inputs. And then we're using all of this information then to get an idea of what the emissions to the city environment are. We're then working with a river model, so this is Antonia's based on Antonia's work, so Antonia is somewhere in the audience, so she can explain it if we get any hard questions. But basically this is based on Antonia's modelling work of surface waters that basically covers the different processes that happen in terms of the aggregation of the particles in the water, deposition to sediment, and so on. So by combining the emission models and also the surface water model then, we can begin to get an idea of the potential exposure of the river system in York to nanoparticles and also the fate of those particles as they enter into the river system. And we're splitting the city up into boxes. So what we'll be able to do then is get an idea of emissions into different boxes as we go through the rivers in the city to get an idea of the spatial exposure of the city to sort of engineered nanoparticles. And this will then fit into a sort of GIS system. So this is a map of the river and the sort of hydrological system of York. So you've got all the different streams and ditches and drains and things that are sort of worked into this map. And we have other data relating to the drainage system. If we can then begin to apportion different activities across the city to different types of nanomaterials, we can then get an idea of emissions to the different parts of the water network. And through this type of approach, then we can then begin to draw a picture of what the exposure of the surface water and ultimately also drinking water would be over time. So just to finish then, hopefully that gives you a feel for some of the work that we've been doing. There are also tools and frameworks available now for environmental exposure assessment of nanomaterials. We've been using some of them, so the stuff that we've been doing with the drinking water suggests that for most of the current products, probably the environmental exposure, certainly via drinking water, is not going to be that important compared to the day-to-day use of these products. That could well change, though. So as we sort of diversify in terms of the types of products we use, and perhaps go to more sort of sophisticated materials, then perhaps the environmental exposure might become important, and we should be considering that. I think that this idea of beginning to sort of consider exposure at much sort of higher spatial and temporal resolutions is the way forward in terms of understanding exposure of us and the environment to both nanomaterials and other contaminants. And this is the way that we're sort of heading with this idea of getting a whole city model with all of the different environmental compartments so we can get an overall exposure of an individual through their lifetime. But the weakest link in all of this is the usage information. So a lot of this stuff, we really need good emission data before we can really get any meaningful data on what exposure is, and that is really lacking at the moment. And a lot of what we're doing is really guesswork, and it's using the sort of assumptions where we go to a shop, we look at particles, what products contain particles, what products don't contain particles, and it's really difficult to get an idea of what is used, and we really need that before we can begin to do this properly. So I'll stop there. I'd just like to thank a few people. So it's a mixture of PhD students and collaborators, and then the people who funded some of this work. So DEFRA and DWI have funded the sort of drinking water work, and then the European Commission are funding this work we're doing in terms of developing city models for contamination in general. So thank you.